All right, in this video, we're going to look at the graph stacking notes. So this would be Physics Journal 7. And the question that's going to guide us is if you want to have one of the graphs of motion, meaning position versus time, velocity versus time, or acceleration versus time, how can you figure out uh, the others, meaning, right, if you have one of them, how do you get the other ones? So the big idea for these nodes is each graph is the slope of the one above and is related to the area of the one below it. So, or area under the curve. So let's say you have a position versus time graph and we want to make the velocity versus time graph. Well, you simply find the slope at any given time and right, so you would find the slope right in here, that would tell you the velocity right here. Or you could find the slope right here, and that would tell you the velocity right here, or so on and so forth, right? This slope obviously steeper, so this velocity obviously higher. And that's true when you go velocity from position versus time to velocity versus time. It's also true when you go from velocity versus time to acceleration versus time, right? Note the velocity of this is constant and positive, which gives us a constant and positive acceleration. So then to go back upwards, right, then you're going to find the area underneath your graph. So for this one, if you wanted to figure out how far you've gone, right, what you would do is you would find the area. Let's say I want to know like how far have I gone right here? Well, in that case, I would find the area underneath this graph right here. And that would tell me the area underneath the graph. Or I could find the area underneath my velocity or my acceleration versus time graph, which would be right, some sort of rectangle that would tell me what my velocity was at a given point. So to work my way upwards, I find the area underneath the graphs to get the value of the graph above, and then when I'm working my way down, I find this about the slope that tells me the value of the graph below. So if I found the slope right here and it was 3, that would tell me that the right the velocity right here is 3 meters per second. And if I found that the slope of this graph was like 2, then that would tell me the acceleration was 2 right here. And then same thing, if I found the area underneath the graph right here was, 6, that tells me that the accelerator or the velocity right here is 6. And if I had found that the area underneath the curve right here, which would be a triangle, right? So 1/2 base times height, that if I found that the area of that was like, let's say 10, that would mean that I had gone 10 meters right here. So that's what that graph is trying to tell, or those nodes are trying to tell us. So if we take a look at an example problem here, what we're given the velocity versus time graph, and we are asked to find the position versus time graph and the acceleration versus time graph. So let's do the kind of hard one first, and let's try to find the position versus time graph. So we're going to go from the velocity to the position versus time graph. So first up, let's remember that the area underneath the graph is going to tell us the right, the position. So if I want to find the position on this dotted line right here, I need to find the area of this triangle. So find this area right here. So that area is a triangle, right? So it's 1/2 base. So 1/2 times by 4 times by my height, which is also 4. And that's going to give me 8 meters, right? So that goes right here. So now let's think about what the shape of that graph is. Remember that that it's since it's speeding up, it's going faster and faster and faster. The slope is going to get steeper and steeper and steeper. So it's going to start out pretty flat, and then it's going to get right steeper and steeper and steeper up to that point, right? But I know that it's going to end up here at 8. Then we do the next part. So the next part would be this rectangle right here. So it's a rectangle, so it's just right base, which is 2 seconds, times my height, which is 4 meters per second. So that gives me another 8 meters. So I'm at 8 meters. I'm going to go to 16 meters, right? So that's going to be linear. It's going to look like that because it's right because you're going at a constant speed. So a constant speed is going to give you a linear line. Then the last part is, right, it's another triangle here. So we're going to find the area of all of this area. The area of that, it's a triangle again. So the area of a triangle is 1/2 times the base, 2, 4, 6, 8. 8 times by your height, which is 4. Oh, it's not 14, 4. Sorry. 8 times by 4 is 32, times by 1/2 is 16 meters. So I'm going to go from 16 plus another 16. So that means by the time I get to 14 seconds, 14 is right here, I'm at 32. So, right, because 16 plus 16 is going to give me 32. So that means I'm right here. And let's remember that this thing is slowing down. So if it's slowing down, it's going to basically flatten out. So by the time it gets to here, it's going to be real flat. And so it's going to kind of look like that. So that's going to be your position versus time graph because, right, so that we got each point from looking at the first one, we figured out that we went 8 meters in the first 4 seconds. So that gave us this point right here. The shape was determined by knowing that we go slowly, so our slope starts flat and gets steeper and steeper and steeper. Then we found, right, that we went another 8 meters. So, right, we went from 8 to 16 meters. So that told us this point right here. The fact that we're traveling at a constant velocity told us that it was a linear line. And then we have to go from that steepness, right? Then during the next part, we found that the area of that is 16 meters. So then we went another 16 meters. That told us that we ultimately, after 14 seconds, are at 32. And because you're slowing down, the line has to get flatter and flatter and flatter. So that's how that part happened. All right, so then let's look at the last part. The last part is we're going to take the slope of this graph and we're going to use that to tell us what our acceleration is. So if we kind of follow this, the first slope for the beginning part is 1 because it goes up 1, or let's do 2 instead. It goes up 2 over 2. So the slope for that is 2 over 2, which is just 1. So that tells me my acceleration for that chunk is 1. I don't need to do any math for this part. The slope of that is 0. So, and the slope for this last part, right, it goes, let's see here, over 2, down 2. So rise over run would be -2 over 2. Oh, sorry, -2, sorry, messed this up, down 1. So, right, because it goes from 4 to 3. So it goes over 2, down 1. So it's -1 over 2, which is, of course, -1/2. -1/2 would be right here. And it holds that slope the entire time. Right, it has that same acceleration the entire time because you have the same slope the entire time from 6 to 14 seconds. So that's what your acceleration graph would look like. I hope that makes sense. If not, don't hesitate to reach out and talk to me. But thanks for watching.